Good evening. Today we are going to see the theorem of three moments, and in this we are going to discuss only equation of theorem of three moments. This is also known as Clapeyron's theorem. So three moments so itself indicates this theorem is applicable for two spans, because when we will get three moments if we are two span and three supports, three support moments, so it can be applicable. So moments, it can be applicable for a continuous beam only. So we are like this, then we can apply this for A, B and C. We can apply for propped cantilever also, provided we have to consider a dummy equation to this. This is very clear. Again, this theorem is applicable for indeterminate beams. And propped cantilever is indeterminate, so we can apply to it. And then now here we will get one this span, this is second span. So this is applicable for two span and three moments. So moment at A, moment at B and moment at C. Now we will see this equation. So we have this also known as Clapeyron's theorem and applicable for a continuous beam. Now we have this beam which is continuous. Out of this we are going to consider part A, B and C. Now in this you have to consider each part separately. So we have to consider AB separately and we have to draw free body diagram for this. Then we have to find area of this free body diagram, which we will denote it by A. So A1 will be area of free BMD. Then we have to find X1 bar for this area, and that is from left. If I have left span, then centroid of that area should be calculated from left. And now we have second BC. Again, we have to draw free body diagram for BC. Sorry, free BMD, not free body diagram. So this is free BMD. And this is also free BMD, free bending moment diagram. And then here also we have to find A2 area of free BMD. Here I have written correctly. So A2 area of free BMD, and X2 bar, this is centroid of this from right. So from right, so from left means from A in this diagram, and from right means from C. So in this you have to keep in mind, for left span centroid from left hand and for right span centroid from right hand. Now we will draw free BMD for AB. So we have this free BMD. This is parabola. So exactly we are not going to plot it. So let us we have this will be the free BMD. A1 be the area of this and X1 bar be the distance of centroid from left hand. So this is X1 bar is from A, because we have this as left span. Now we have BC as right span because we are applying equation for BC. ABC, equation for ABC. So we have to take X1 bar from A and X2 bar from C. That is left and right letters. So now second we have BC. We will draw free BMD for beam BC. A2 area of this free BMD, X2 bar. Now you can see we have this X2 bar is centroid distance from C. And now we have Clapeyron's theorem. I will not go for derivation of this. So we have MA into L1 upon I1. So we have L1 be the span of this, I1 be the moment of inertia of this, plus, and MA we have moment of this, that is final moment or fixed end moment, plus 2 MB. Now MB we have that will be center MB, then we have that will be L2 comma I2. So we have L1 upon I1 plus L2 upon I2, as this is common for both span. So it is taken twice, L1 upon I1, L2 upon I2 plus MC into L2 upon I2. So this is left part, which is same. Now if we will go to the right part, so we have in this right part, that is 6 A1 X1 bar upon I1 L1. So 6 A1 we know area, X1 bar that is centroid from left, I1 moment of inertia of that span, L1 we have span of AB or first span, and similarly we have 6A2 X2 bar upon I2 L2. Now till this we are going to use formula when we do not have any sinking of support. So I can say no sinking. No sinking of support. Now if support sink, then we have to add two terms in this. So in this we have, this is first term for span AB. This is second term for span BC. Now you can see 6E I1 delta 1 upon I1 L1 and I2 delta 2 upon I2 L2. Do not cancel I in this I1 because this I we have denominator of all and that will be cancelled in that case. Now how we will calculate delta 1 and delta 2? For this delta 1 and delta 2, we have for delta 1 and delta 2, support B will considered as, support B is considered as a reference. So now weightage are given to all support as a reference. That means we have, if A we have, this will be ABC. So this is point A, we have this is point B, and we have this point is C. Then we have, let us this will be sink by delta A, this will be sink by delta B, and this will be sink by delta C, which will be again down. So we have this will be delta A, then we have this will be delta B, and this we have delta C. Now how we will get delta 1 and delta 2? Delta 1 is difference between B and A. And now how we will calculate this difference? This will be reference line. If we have A above this, we will have plus. If it is below this, we have minus. So now what will be delta 1? So we will get delta 1 that is equal to delta B minus delta A, and this value we have plus. Now we have this will be delta 2. Now you can see this, your value, this is below B, and then delta 2 you will get it as delta B minus delta C. Same we will get, but if we will calculate this, then you will get this value as negative because delta C is greater than delta B. So reference in this is B. For X1 bar reference is A, and for X2 bar reference is C. So this part we have to consider only if sinking is there. Only if sinking is there. Sinking is there. Now next part we can see, if we do not have, or my value of I is constant, then I can write it as I1 is equal to I2. In this case, I from all, and that is equal to I also I will mention, and then I will cancel from all, and we will get it as MA plus L1, I we have cancelled, plus 2 MB L1 plus L2 plus MC into L2, 6a1 x1 bar upon L1 plus 6a2 L2 bar upon L2 minus 6ei delta 1 upon L1 plus delta 2 upon L2. So this we are going to use if cross section is same. Cross section same, that means I1 is equal to I2 is equal to I, and you can see in our equation we have I in denominator of all the terms, and that will cancel, and therefore I told you don't cancel this value of I, because this I now we have taken outside, which is in numerator, and denominator I gets cancelled from all. So if we have to keep in mind this formula, second formula we can be derived from first. So this is all about your theorem of three moments. Now we can have special cases in this. If we are loading as UDL, and in that case we know if we have W is the load, L is the span, then we have free BMD. Now we have this as free BMD, and that free BMD we know this is WL square by 8. So this is free BMD. Now we will calculate A1. So now this is 2 by 3 span upon span into ordinate, that is height. So 2 by 3 into L into WL square by 8. And from this we will get these two gets cancelled, and this will be 4, and we will get this value as WL cube by 12. Now x1 bar we can have from left or we can have from right, will be same. So UDL may be on first span or in second span, then also your values are not going to change. X will remain same from left and right, which will be L by 2, and therefore we can calculate 6a x bar upon IL. Now 6 area we have calculated, this is WL cube by 12 into x bar is L by 2 into 1 upon IL, and this LL now gets cancelled, and then we have 2, then we have 3, and then we have this as 4. And from this we will get value of 6a x bar, that is equal to WL cube upon 4i. So we can use this direct equation if we have UDL in that case. Then if we have concentrated load, but this concentrated load should be at center, then only we can use this simplification. So now in this case you can see we have simply supported bending moment, or I can say free BMD. We have PL by 4. P we have concentrated load at center. Now we have A1 1/2 base into height, 1/2 L into PL by 4 gives us PL square by 8. Now x1 bar from any side we will have L by 2, and then we have 6a x bar 6 into, now this will be my area PL square by 8 x bar L by 2 into 1 by IL, because we have 6a x bar, so IL is there in denominator. And then we will find this value, we will get it as 3PL square upon 8. You can see this 2 3s are, and then we will get 3 upon this 8. So 1L gets cancelled and I is there. So we can use 3PL square upon 8I if we have concentrated load at center. So this equation we can use, or we can go directly also, no time is required in that case. So thank you. This is all about your formula which we are going to use for Clapeyron's theorem, and then you can solve the problems of this. If you like the video, then make it like and subscribe if you are not subscribed this channel. So thank you. We will stop here only.